The sequence 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6 is neither arithmetic, because you cannot add a common difference to each term, nor is it geometric, as you cannot multiply a common ratio to each one. In fact, this is its own special sequence, which we refer to as a harmonic sequence. The harmonic sequence only has an explicit formula. We're going to say h sub n equals 1 divided by n. There is no recursive formula. When we look at this sequence of 12, 6, 4, 3, and 12 fifths, are you recognizing it also as a harmonic sequence? In this case, where 12 is being divided by n. Looking at the first four terms, 12, 6, 4, 3, what we really see is that they're just reduced fractions of the harmonic sequence. You might get clues when you start looking at the 12 divided by 5 and the 12 divided by 7 because they don't reduce. But then again, they're surrounded by 12 divided by 6, which is 2, and 12 divided by 8 is 3 halves. So, as you conclude the remaining parts of the sequence, you can see that all this sequence is really a harmonic sequence just being multiplied by 12. Let's look at a new sequence of 1, 1, 2, 3, 5, and 8. What number comes next? Did you say 13? If you did, how did you compute it? The way I would have computed it is I would have gone 5 plus 8, and that equals 13. So if I ask again, what number comes next, how about now? Did you say 21? And if so, how did you do it? The way I did it is 8 plus 13. We'll do it one more time. What number comes next? In this case, the answer is 34, because you took 13 plus 21 and you came up with 34. The sequence that we've generated is known as the Fibonacci sequence. There is an explicit formula, but the easiest one to remember is the recursive formula, and that's where you need three pieces. You need a first term defined. You need a second term defined. And then you need this part of the formula to kick in, starting with the third term, where you take the previous term, that would be this one, usually that piece, and then you would have to go 2 terms back, add them together, and then you'll get the new term. Now, on the off chance you want to learn an explicit formula, feel free to use the one that's listed below. Given the Fibonacci sequence, let's look at the next term, or in this case, the 10th term. We'll take the bottom equation of the formula and we'll substitute 10 in for n. And we'll say a sub 10 equals a sub 10 minus 2 plus a sub 10 minus 1. But 10 minus 2 is 8, 10 minus 1 is 9, and we'll rewrite it simply as a sub 10 equals a sub 8 plus a sub 9. Now a sub 8 is 21, a sub 9 is 34, so when we add those two numbers together, we come up with the 10th term of the sequence being 55. We'll practice this method one more time by finding the 11th term of the Fibonacci sequence. Using the bottom formula and substituting 11 in for n, we'll say a sub 11 equals a sub 9 plus a sub 10. A sub 9 was 34, and we just computed that a sub 10 was 55. The sum of those two numbers is 89, which will be the 11th term of the sequence. And we can continue to use the recursive process to find more and more terms of the Fibonacci sequence.